Hello friends, welcome back. Now we are starting exercise 2.3. Examples are very simple. The first example, in the figure, let us see the figure first. This is the figure they are given. Don't look at my figures, I am drawing with my hands, but you draw proper figures, okay? This is the figure they are given, A, B, C and P. A, B, C, P, and they are given, this is Q and this is given 80 degrees. Let us see what else is given. If major arc APC is 60 degrees, major arc APC is 60 degrees. I am writing it directly on the figure. On the rough figure you should draw or you should write everything whatever given. And angle BAC is 80 degrees, BAC is 80 degrees. Find angle ABC, we have to find angle ABC and we have to find measure of arc BQC. BQC. These two measurements we have to find out. Okay. Now forget about, problem is very simple. Forget about that. First of all, we'll analyze the figure and we will write down whatever we can find out from here. Simple thing. This angle is 80 degrees. This angle is making this arc. That means intercepting this arc. So we know that this arc measurement must be double of this angle. So it is 160 degrees. So now this is very simple. This is 60, this is 160. So this must be 140. 360 minus 220. If this is 140, then this angle must be half of it. That is 70 degrees. Now what other information I can get? If this is 60 degrees, then this angle must be half of this arc. That is 30 degrees. Okay? Yeah, only this much information I can get from this figure. Whether it is required or not, that is different matter. Now it must be true because 70 plus 30, 100 and 180 means triangle 180 degrees is there. Now let us see what they have asked. I told you that this all information may not be required to solve, to find out these two. But I am just analyzing, I am just showing you how to analyze the figure, how to write down, find out and write down what we can see or what we can find out from this particular figure. Okay. Now let's see what is angle ABC. Angle ABC I find out 30 degrees. What is measure arc BQC? BQC is 160 degrees. Actually this was not required, this was not required, but still I shown you that how to find out how to decide an angles. So this is very easy. Such kind of examples are there in this chapter. Let us move to second example. Find the radius of the circle passing through the vertices of a right angle triangle. That means this is a right angle triangle they are given. And also they are given that the side AB, that is sides making right angles, are 8 and 6. Now let us consider that O is the center of the circle which is passing through all the vertices of this right angle triangle. What we have to find out? We have to find out the radius of this circle. Now by the Pythagoras theorem you can easily find out what is AC because this is right angle triangle. So please pause your video here and quickly find out the value of AC. Now AC is 10. I don't know whether this AC is a diameter or not. I have to decide whether this is a diameter or not. Now in this circle, this ABC angle intercepts this arc, this big arc. I say X, AXC arc, which will be, this is 90 degrees, so this must be 180 degrees. But this arc also subtend the angle at O, central angle, AOC, which is 180 degrees. And if this angle is 180 degrees, that means it must be a semicircle and this must be diameter of that semicircle. So this OC, that is the radius, is nothing but phi. Very simple. Since this is right angle, this must be the angle, the converse. If the angle is 90 degrees, then that is a semicircle. Okay? Simple example. I just shown you the figure they are given. Now let us see the example number 3. The figure is given something like this. AB and DC are two arcs of the circle which are intersecting each other in the point Q inside the circle. We don't know whether this is a center of circle or not. Just intersecting in point Q inside the circle. What else they say? They say if major arc AD is 25 degrees, I tell you, whatever you see in given, just mark on the rough figure. So AD, they are given 25 degrees. And major arc BC is 31 degrees. BC is 31 degrees. Then find angle BQC. Find angle BQC. We want to find out this angle. Okay. Now, can you see that this is the inside? Okay, arcs is intercepted, etc. is fine. But I want to find the angle BQC. This angle I have to find out. I cannot say that this is 31 degrees because can you see that both the angles are opposite to each other, so must be same. But are they same? No, this is 31, this is 25. So this is not a center. If it is center, then must be equal. But it is not a center. So what I will do? Now in this arc, does this arc subtend any angle? No. Does this arc subtend any angle? No. But suppose if I join this, then this arc, this angle is 31 degrees by 2 and this angle is 25 degrees by 2. Right? Inscribed angle theorem. Correct? Now this angle is the exterior angle. This angle theta, suppose I say, that is BQC, is exterior angle of this triangle, which is equal to addition of remote interior angles. So angle theta will be equal to half, or I can say 31 by 2 plus 25 by 2. 31 by 2 plus 25 by 2, that is equal to 56 by 2, that is 28 degrees. Very simple, very, very simple. Correct? You have to just judge and you have to somehow find out the common angles in the same arcs. Okay? Very easy example. Let us go to fourth example. This is fourth example. Secants containing chord RS and PQ. Chords RS and PQ. These secants of a circle intersect each other at a point A in the exterior of the circle. These two secants are intersecting at A outside the circle. As shown in the figure, if major arc PCR is 26 degrees, what is PCR? This is 26 degrees, and major arc QDS is 48 degree. QDS is 48 degrees. Find angle AQR. Angle AQR, that means they have joined this QR. They have joined AQR. We have to find out this angle. Also find SPQ, that is SP and Q, that means they are joined this also. SPQ means we have to find out this angle plus angle RAQ. RAQ, we have to find this angle also. These three angles we have to find out. But first of all, let us analyze the figure and write down on the rough figure whatever we have understood from this figure. Now onwards, I am not going to call intercepted arcs, inscribed angle and all those things. I'll just tell you that if this arc is 26, then this angle must be 13. Now here also information may not be required, but still I am writing the information, whatever I can see, just for the habit. Okay. Now can you see that the same arc is making this angle, so this also must be equal to 13 degrees, half of this, correct? So I got these two angles. I got which angles we have to find? AQR and SPQ. See, AQR and SPQ, these two angles we have already received. We got these two angles. Now we have to find out this angle. Now how will you find that angle? Now can you see that this arc 48 degrees, some more information I got, 48 degrees, that means this angle is half of 48, that is 24 degrees. Similarly this is 24 degrees. Now maybe that information is not required, but still I am finding it out. Okay. So now there are so many varieties or so many ways you have. First of all, if this is 24, this is 180 minus 24. This is 24, this angle will be equal to 180 minus 24. Can you see this triangle ARQ? In this triangle ARQ, you know one angle, interior angle 13, one exterior angle you know 24. The exterior angle 24, this 24 will be equal to addition of remote interior angles, that is 13 plus this angle I say theta. So theta will be 24 minus 13, 11 degrees. First of all, write down whatever you have found out from this figure. What I saw in this figure, yeah, here there is a quadrilateral, but I have no use of quadrilateral. I may find these two angles, but still this fourth angle will be missing, so of no use to me. Now is there any triangle? Yes, there is one more triangle. This triangle is also there. This triangle is also there. This is also exterior angle, and two remote interior angles, addition, that also can be done. One more triangle is here. Now in this case this is exterior angle, two remote interior angles. In that way also it can be done. So the problems are very easy. Don't just get confused by the figures, complexity of the figures. Don't get confused by that. First of all, whether it is required or not. See, when you practice so many examples here and analyze so many figures, you will automatically come to know in the exam what is required and what is not required. In this figure, two chords AB and CD. These are two chords AB and CD. These are two chords are parallel to each other. These two chords are parallel to each other. P is the center of the circle. P is the center. Show that angle CPA means this angle equal to angle DPB. Angle DPB. These two angles are to be shown equal, congruent angle. We have to show them. Now how will we do that? First of all, let us analyze the figure. Let me join, if I join this, what will happen? What will happen if I join this? That means this angle, this arc is making this angle, subtending this angle, and same arc is making this angle. So these two angles are equal. This is x and this is also x. Correct? And can you see this? BA and CB, that is making this arc. So this is y, correct? And this is also y, correct? This is what I found out from this figure. So this is what I found out from this figure related to arc of the circle. What other information by my previous knowledge? Yes, AB and CD are parallel, okay, and I am just joining this line. So these are the alternate angles, X and Y, and X must be equal to Y, alternate angles. So X and Y are alternate angles, means those must be equal. So this is not Y actually, this is also X and this is also X. So it is proved. This is how I proved that this angle equal to this angle. Simple thing. So take care of one thing, whenever you get the parallel lines, whenever you see the parallel lines, try to join the parallel lines. Okay, so whenever you get a parallel lines, draw this. So you 100% know that these angles are equal or these angles are equal. This is from your past knowledge, you can judge and you can write and make use of it in such exam, in such problems. So this is very simple. So first, as soon as I saw two parallel lines are there, I drawn one line, cutting them. And so these two angles are equal. Now I am just explaining you this problem. You have to write, okay, since you have to write like this, angle BCD is an inscribed angle or is an angle subtended by RDB, and angle DPB is also an angle subtended by RDB. So both are congruent and so on. All these things you have to write. Correct? And after that you can make use of these theorems and prove it. Here I have taken XX, same thing you can do. Same thing you can do. As I proved this, suppose this angle is X. So in future, in the further statement, you don't have to write the names of those angles, because you will 100% miss the names of the angles. I am very sure about it. Minimum 80 papers out of 100 papers, students make mistakes in writing the names of an angle. In first line they will write this angle name correctly, second line they will do some mistake in that, writing the name of the same angle. So I am alerting you that either you take XXYY something like this, or ABCD, angle ABCD you can take, so that you can easily read the angle and write here. But at the end you have to write a statement, and hence angle APC is equal to angle DPB, because that is what asked. So that you have to write, that statement must be there. You cannot write angle X is equal to angle X. Okay, the final statement should be whatever they have asked must be the final statement, and you have to write in that fashion only. Here I am just explaining you how to solve this example or how to solve such examples. Okay, let us go ahead. If major arc XAZ, that means XAZ, this arc is equal to major arc YBW, this arc, prove that XY is parallel to ZW. XY is parallel to ZW. These two arcs are equal. That means the angle subtended by these two arcs will also be equal. So this angle equal to this angle, and these two angles are equal, but those are alternate angles, so these two lines are parallel. So this is just a test of alternate angle in parallel lines. Let us solve the last example of 2.3, a little bit complicated example, lot of things to be find out. Let us read the example first. Circle with center O, just check here that none of the lines are passing through the circle, okay? And BC and ED are parallel. BC is parallel to ED. BC is parallel to ED, okay? Now we have one transverse also, so alternate angle theorem can be used there, okay? Keep it in mind. Major arc BC is 94. We have to write everything, whatever we know. BC is 94. Major arc ED is 86. ED, this ED is 86. Angle ADE is 8. Angle ADE is 8 degrees. Okay. This is what the given is. Now what we have to find out, that will mark in red. AE we have to find out. Then major arc DC. DC we have to find out. Then major arc EB. EB, this complete, we have to find out. Then angle DAB. Angle DAB. This angle we have to find out. Then angle ECB. Angle ECB. This angle we have to find out. And lastly, we have to find out angle CBE. CBE. This angle we have to find out. So first let us understand what we know from this figure. Let us analyze the figure. Okay. These two things are parallel. These two lines are parallel. This is transverse. And so this angle must be equal to this angle. Both the angles are equal. This angle is equal to this angle. Now here, if we want to find out this angle, see the major arc. So 86 plus this angle will be half of that. We want to find out this angle, then the whole arc half is the angle. Correct? What else we want to find out? This angle. If you want to find out this angle, then this complete arc, half of this complete arc, we can find out the angle. But if these two angles are equal, then don't you think that this arc CD and EB are also equal? That means this arc EB and this arc CD are also equal. Now we want to find out EA. EA is straightforward. Since this angle is 8, so EA is double, 16. So let us write down whatever we are finding out. This is 16. Now we have to find out the remaining arcs. Now we know that the total measurement of circle is 360 degrees. Since EB and CD are equal, I will take one part. That is, now it is BC plus ED plus CD plus EB is equal to 360 degrees. Let us write it down. BC is 94 plus CD plus ED is 86 plus EB is equal to 360 degrees. And so (180) plus CD plus EB is equal to 360 degrees. So CD plus EB is equal to 180 degrees. Okay. Now we have got CD plus EB is equal to 180 degrees. But we know that these two angles are same, and so these two major arcs are also same. So if CD equal to EB, then each of the CD and EB are 90 degrees, half of this. Correct? So let us write it down there. So we got CD is 90 degrees and EB also we got 90 degrees. EB also we got 90 degrees. Correct? Now let us try to find out the angles, whatever we need. Now they have asked us this angle EBC. Now can you see which arc it is intercepting? 86 plus 90. Okay. So this angle must be equal to half of 86 plus 90. This is angle B. Half of this. So this angle B here is 88 degrees. Correct? Now we want this angle. This angle must be half of 90 because it is intercepting the arc of 90 degrees. So this is straightforward. This is 45 degrees. Now we want this angle. Now this angle is intercepting this arc, 90 plus 94. So that will be, that angle A will be equal to 90 plus 94 upon 2, half of that, as per inscribed angle theorem. So this is equal to 184 upon 2, that is 92 degrees. So we will write here 92 degrees. So we have found out everything what we want. Okay. EB we have found out, this was straightforward, this we have found out, and all angles we have found out. Okay. So this example is little bit complicated, but not that complicated. It is actually easy, but just tedious. So many A, B, C, D, E are there, and you have to write down the names of the angles and so on. So here also you can do same thing. Instead of writing E, B, C and all those things, you can write X, Y, Z, alpha, beta, gamma, whatever it is, names of the angle. To this also you can give some name, that is major arc, or the arc CD is P or Q, then this is P or Q, so that you can easily write that arc P equal to arc Q as angle E. You can give some name, angle E and angle C are alternate angles in parallel lines. Okay, like this if you solve, it will be very easy for you to write down the example. Okay, otherwise you have to remember and you have to carefully see while writing the names or telling you the angles also. Even I was also confused. Now it is B, E, now find out where the B is, where the C is. So instead of, you can write the small letters, the names of the arcs and the names of the angles. So in that way it will be very easy. So friends, here we have finished exercise 2.3 and now we will move ahead to next topic. Thank you very much.